Hello, everybody. So my project was on capturing seismicity from a vibra-size survey and local tectonics with a surface DAS array at Forge. So this summer, I've been working with a new kind of seismic sensing technology called distributed acoustic sensing, or DAS. So how does DAS work? DAS works by firing a laser into a fiber optic cable from a receiver, and that laser bounces off of natural impurities within the fiber, and the receiver measures the backscatter of light coming back. And the properties of that light can change based on movement in the ground from seismicity. So based on the properties changing, the receiver can measure strain on the cable. And this technology shows promise for significantly enhancing the seismic network. So we wanted to test this technology in the context of Forge. So we installed our sensors at Forge, which is the Frontier Observatory for Research into Geothermal Energy, which is located north of Milford, Utah. You can see a map of the Forge site here, local earthquakes, our DAS array outlined in red, and nearby seismometers, which we compared our data with. Forge experiments with enhanced geothermal systems in order to create energy. In enhanced geothermal systems, as you can see in figure B, they pump water into hot, dry rock, create an existing fracture net, create or augment an existing fracture network, then heat up that water within the rock, pump it back up to the surface, and use the resulting steam to generate energy. And naturally, that creating fractures creates induced seismicity, which is often on the scale of microseismicity. So we wanted to test to see if DAS was able to capture microseismicity at the site. We were also testing to see if DAS could capture signals from the vertical seismic profile that was deployed at that site, which you can see in C is from a vibra-size truck coming to the site, vibrating the ground and sending seismic signals into the ground, which get reflected off of certain features. And those reflections are recorded at the surface and can be used to measure certain features in the subsurface. And in Forge's case, they use seismic imaging like this to monitor the progress of the fracture network. So our goals were to see if DAS can detect both signals from this vibra-size survey and microseismic signals from local tectonics. In order to do this, we compiled a catalog of events that happened during our experiment time period, and we made plots of the seismometers on IRIS, and we looked for local seismicity and signals from VSP survey. And then using the seismometer plots, we could narrow down the time frame that the earthquake signals should hit the DAS array. And we were able to visualize that time frame in Python in different ways, such as particle velocity or strain rate. We were able to apply certain filters to bring out the signal, and also able to visualize the signals as a mean particle velocity over time. So for our vibra-size surveys, these are our results. And as you can see for the first plot, we visualized a 31-minute time period of the vibra-size survey. And you can see there's different shots deployed during this time period. We also visualized it in particle velocity using DAS signals, as you can see in B here. And in C, we visualized it as mean particle velocity stacking of channels over time. And as you can see, they compare very closely to the initial seismometer plot. You were also able to zoom in on certain signals, such as the time period where 3 shots were deployed, and on a single signal from the vibra-size survey. So, and these possible signals up here as well could be reflections in the data, which means that DAS would be useful for seismic imaging. We were also able to detect multiple microseismic events, the most apparent being a magnitude 0.7 event on April 13th. And we could see that event here in the IRIS plot, and we can see that our signal in the DAS particle velocity plot in A lines up with the timing of the S wave in the initial seismometer plot. We can also see in the mean particle velocity stacking of a single channel that signal also matches up with that time. So we showed that DAS is useful both for microseismic detection and for detection of VSP signals. And hopefully facilities like Forge can use this technology in the future for seismic imaging and monitoring. So I'd like to thank all the people who contributed to this project, and also acknowledge the native lands that this project was performed on. So I'd like to open it up for questions now. Thank you.
Thank you. That was great. So floor is open for questions. You can raise your hand or type it into the chat. Was the DAS optical fiber buried, and did you experiment with different fiber and placement strategies? Bob would like to know.
Yes, it was buried horizontally under the ground, 2 to 3 inches under the ground. That was just our fiber, but there were other fibers at the site that were vertical downhole DAS fibers as well. And we want to compare our data to those signals in the future. And we have done preliminary observations on that, but we don't have enough to directly compare the two yet.
Says thanks. I have a question. Were you surprised by any aspect of your research this summer?
Yes, I was really surprised by how much the scaling mattered for visualizing these signals, because they could be not visible at a certain scale, and then you would add an exponent and the signals would come out. So it had a lot to do with the sampling rate, which was really high, 2,000 samples per second. So a lot of that had to be taken into consideration when doing visualizations. Did any critters chew on the fiber? Not that I know of. It was buried underground, so hopefully not. Oh, Matt
Manny
says yes.
yes.
Any preliminary estimate of the max distance to which you could see the vibra-size signals? We mostly just looked for signals that were close to the array, and the survey kind of ran about like a couple miles adjacent to our array. So we could detect most of those signals that were deployed in the array.
I have a quick question, Halina. Were you interested in seismicity things before you did this project, or was this something new?
I was interested in plate tectonic processes, but I'd never done like actual seismology before, but this project definitely got me interested in that.
Okay, Glenn, we have time for one more.
Yeah, this is a real quick one. So did this technology allow you to increase the catalog of completeness to much lower magnitudes rather than using other seismic instruments?
No, we only searched for earthquakes that were already detected by seismometers at the site. So we didn't really enhance the magnitude to which we could detect earthquakes, but we did enhance the sampling rate of those signals and the distance over which you could detect it.
Okay, thank you, Halina. If you have more questions for her, you can put them in the chat or send an email. But we are going to move to our next speaker,